Right. So chapter 2, talking about chemistry and molecules, specifically macromolecules. We're going to start off with just some general chemistry. So a lot of the first section of this chapter is probably going to be review for some of you. So we're going to be talking about things like elements and parts of an atom and what ions are and things like that. So first thing, just some terms so that we're all on the same page. So elements, an element is just a substance that can't be broken down chemically into any other substances. So you can see some examples here of some different elements. So gold, carbon, two different examples. We've got coal and diamonds. These are both made out of carbon. It's just that they're arranged differently as far as their atoms to make them into these two different materials. Copper. And so elements are anything that you can find on what object. If we were looking for the elements, you could find a list of the elements where? Yeah, on the periodic table, right? So you can find all of the different elements on the periodic table. What are some other elements that you know? So like I said, I've got here gold, carbon, copper. So what are some other elements that you know of? Either that you know from everyday life or you just know as maybe your favorite element. Okay. So elements are substances that are ones that can't be broken down chemically into other substances. Basically, what they are built out of all the same types of atoms. And so atoms are the smallest part of matter. So you can see there a bit of matter that can't be subdivided any farther without losing its essential properties. So basically, if you take an atom apart, it can no longer be that substance. So you can have an atom of gold, but if you take that atom apart into the different parts, it no longer is going to act as gold. And so we've got those two terms. So as far as elements go, we're talking biology, and so organisms are made up of different elements that can then be made into compounds. Compounds are just combinations of elements. And so there are 25 elements that are commonly found in the human body, and 4 of them make up most of us. So you can see that oxygen is the one that makes up majority of our atoms. The next one that's the most common is carbon, and this is why we're considered a carbon-based life form, because most of our molecules in our body, or most of our compounds in our body, contain carbon, and we'll see that as we go through the macromolecules. Hydrogen, and then nitrogen. So very often we see the big 4 called CHON, C-H-O-N, just as an easy way to remember them. And so we've got oxygen, carbon, hydrogen, nitrogen as the big 4. And then, like I said, there's 25 elements. And so you can see some of the other common ones. Some of these might sound familiar. Calcium, we know that is used to build bones. We'll see phosphorus when we talk about things like nucleic acids. Potassium and sodium, these guys are used the same way. They're used to actually do things like muscle contractions. Same thing with chlorine. Sulfur, we use sulfur to build some of the molecules like proteins. And then there are trace amounts of 15 other elements found in your body. So what I'd like you to do now is just in the question, tell me what other elements you are aware of that we need. So that's the other 15 elements, right? So these are elements that you might be finding in vitamins and things like that. All right, so the next thing to take a look at is parts of an atom. And so like I said, for a lot of you, this is probably review. And so we're just going to quickly look at the structure of an atom. So we've got the nucleus, and the nucleus is going to contain two of the parts of the atom. And then around the nucleus, we find the third. And so the nucleus is going to contain protons and neutrons. Now, in some atoms, like this hydrogen atom up here, we just have protons sometimes. Protons, you can see, are given the symbol positive, and that's because protons have positive charges, so that's how I always remembered it. Protons are positive. And so in something like a hydrogen atom, you can see there's just one proton, but down here in our carbon atom, we've got 6 protons. And then in the nucleus, we also find neutrons. Neutrons are neutral, so that's why they don't get a sign. And so the neutrons and protons are going to hang together in the nucleus. And in the carbon atom here, we've got 6 neutrons, no neutrons in the hydrogen atom, but you can get hydrogen atoms with neutrons in them. We'll take a look at those here in a second. And then you've got the last part of the atom, which are the electrons. Electrons have that negative charge, and so they are going to stay out of the nucleus in what you may have heard called like the electron cloud. It's basically the space around the nucleus where those electrons are going to hang out. So atoms' electrons are going to determine how and whether those atoms are going to bond with other atoms. And so the electrons arrange themselves into shells. So you may have noticed in that previous slide that the carbon had 2 kind of rings around the nucleus of electrons, and that would be the electrons' shells. So let's take a look at a couple of these guys. So we've got oxygen here, and it's got 2 electron shells like the carbon did. And these electron shells get filled up with electrons. And in order for atoms to be kind of happy and stable, the electron shells need to be filled on each level. And so the first one can hold 2 electrons. And then the shells past that, for how we're looking at it, are going to be able to hold 8. And so here you can see the first one got filled with 2 because oxygen has 8 electrons, and that leaves 6 electrons to go to the next shell. But what that leaves is 2 vacancies, 2 openings for electrons. And so what this means is that oxygen isn't going to be a happy, stable atom until it's able to fill those gaps. And so it will fill those gaps by sharing electrons or taking electrons. And we're going to take a look at how that works with a couple of different bonds. So you can see over here, like I said, oxygen is an unstable atom. Hydrogen is an unstable atom. So you can see it's missing an electron for its first level. And then nitrogen is also going to be missing some electrons. In this case, it's missing 3. So all of these guys are going to be unstable or unhappy electrons until they're able to fill those spaces. On the other hand, these guys over here, helium and neon, they are stable atoms. So they have full electron shells. So helium has 2 in that inside shell, so it is good. It doesn't need to find any electrons. Same with neon. Neon's filled the inside one and then the next one out. So it is good to go. It won't need to interact with any other atoms in order to fill those shells. So then we come to carbon. So carbon is the one that makes up a good chunk of our atoms. So why carbon? So it has to do with how many bonds or how many electrons carbon needs. So if you take a look at the picture, how many bonds or how many electrons does carbon need in order to become stable? So if we take a look over here, how many electrons does carbon need to find to become stable? And that tells you how many bonds. So yeah, carbon can bond with up to 4 other atoms, whether it's taking electrons or sharing electrons. And so it has spots to actually make bonds with up to 4 other atoms. And what this does is it allows it to basically be the best tinker toy, or kind of a weird Lego. And so it's going to mostly bond with the other elements that we saw that make up most of our atoms, right? It's going to mostly bond with oxygen, hydrogen, nitrogen, and other carbons. Those are the elements that it likes to bond with the most. And so you can see that down here in the picture of different carbon compounds. We've got carbon and oxygen to make carbon dioxide, proteins with carbon, oxygen, and nitrogen. The little white ones are hydrogen. And then sugars, which are all carbon, hydrogen, and oxygen. So ions, these guys, we're going to talk about them because we need to talk about them in relation to one of the bonds we're going to look at. So ions, these are atoms that are going to either give up or steal electrons to be able to get that finished outer shell, right? So here we've got 2 atoms. We've got sodium and chloride. And these 2 atoms are going to become ions. Ions are atoms that have a charge. You can see it's got that here. Ions are charged atoms. So how do they get the charge? And what we mean is they're either positively charged or negatively charged. So if we take a look at the sodium atom here, normally sodium has 11 protons, 11 neutrons, and 11 electrons, right? And so when we put the electrons in their shells, you get 2, 8, and then 1 in that last shell. And if you think about it, it's easier to give up 1 electron than it is to go find 7, right? Because that's what they have to do. To make a stable sodium atom, you'd have to either give this one up or go find 7 to fill that ring. And so instead, sodium is going to say, okay, if you want it, take it. And so it will donate that electron to another atom, in this case, chloride. And so chlorine or chloride, it has 17 protons, 17 neutrons, and 17 electrons normally, which means it's 1 short in its outermost shell. And so it will happily take that electron from the sodium. So it'll take that electron. Now this one's gone. That has a full shell. This one's going to come over here. That is going to have a full shell. And now let's see how they become ions, how they become charged. It's because there's that change in electrons, right? When they started, the charge was equal because they had 11 protons, 11 positive charges, and 11 electrons, right? 11 negative charges. But when the sodium gave that one away, we now have 11 positive charges and 10 negative charges. So that sodium is going to be positive because it's got 1 extra proton compared to the electrons. Then the same thing is going to happen to the chlorine, just the opposite direction. There were 17 positive charges, and then there were 17 negative charges until it gained that extra electron up here to make it this 18. Now it's got 18 electrons, so there's one more negative charge. That makes this chloride ion negatively charged.